DuckDB has been skyrocketing in popularity lately, with download stats going through the roof. Just look at this graph from PyPI, and that's just from Python usage. And wait, are you telling me a duck built this database? Well, DuckDB isn't just a fun name, it's a powerful open source analytical database designed to handle everything from quick data exploration to complex data pipelines, and it's already trusted by multiple companies in production. In this video, we'll understand what makes DuckDB so unique, we'll break down its core concepts, show you why it's different from traditional databases, and of course dive into practical examples with code so that you also feel like you have the duck power in the palm of your hand. And in the second part of this video, we'll explore how you can move your DuckDB workloads smoothly to the cloud with MotherDuck, which supercharges DuckDB's features. So let's dive in, pun intended. So why DuckDB? In the past decades, the tech world has often treated big data as the default for analytics. The mantra was simple: if your data is growing and is big, you scale out by using distributed systems with common hardwares, massive infrastructures, and honestly, complex tools to handle it. But this assumption is increasingly being challenged for three reasons. First, most workloads aren't big data. DuckDB represents a counter-narrative to this big data story by focusing on small and medium data. And that's the vast majority of real-world use cases. If you want some real numbers around what is big data, the Redshift team from AWS, another cloud analytical database, reported this data for the common workload. Roughly, we get 83% of users where the query size is up to 1 terabyte and 94% of users below 10 terabyte. And by the way, this is a hard drive today that contains 4 terabytes. So you get basically 2 of these and you cover most of companies' workloads. So this led me to my second point. The hardware you can get today on a single machine is powerful. But it's also that our big data reference has kind of changed. So indeed, back in the days, we had to divide and conquer compute because workloads were too big for a single machine. Today on AWS, you can get up to 24 terabytes of memory. And yes, that's the largest machine, but that's just to give you the big picture compared to what it used to be. And finally, the third point is that distributed system is expensive. You have a lot of I/O network traffic to coordinate things, and development experience is also much more painful. So DuckDB can easily crunch dataset in this range, and the performance and simplicity of DuckDB let you work with large dataset on a single machine, locally on your laptop or in the cloud via scale-up strategy. DuckDB really embraces a new paradigm in database architecture while delivering performance on par with traditional distributed database without the overhead. It also has built-in integration with everything you need for data, would it be reading from JSON, CSV, Parquet, Delta Lake, using AWS S3, Google Cloud Storage, and much more. It even has its own file format, a self-contained, efficient, and ACID compliant format that stores all tables and metadata in a single file with great compression. So now you understand. With DuckDB, you have a complete analytics powerhouse in a single tool. So how does DuckDB work? So DuckDB is an open source in-process analytical database written in C++, designed as a single self-contained binary with all dependencies included. And that later on is often underrated because in the open source world, you may get easily stuck in some spaghetti dependencies and issue with third-party library. But it's not the case here. You get the full package. So let's focus on the in-process part and compare them to traditional databases. So databases generally fall into two categories: OLAP, online transaction processing, databases like Postgres and MySQL. These are optimized for handling transactions involving small updates or queries on a few rows, and they are ideal for fast, frequent operation and are often referred as the operational databases. the backbone of your e-commerce, your banking system, or whatever application you have. Time of a query is typically between 1 to 10 milliseconds. The second category is OLAP, Online Analytical Processing. These are databases like BigQuery and Snowflake that are built for analytical queries. They are great at processing large datasets, computing metrics across many columns, and supporting complex analysis. And query time can go here from 100 milliseconds to several minutes. Most traditional databases, whether OLTP or OLAP, use a client-server architecture, and in this setup, the database runs as a separate process, and applications, the clients, connect to it typically through SQL queries to the server where the data is stored and computation takes place. In contrast, in-process databases run directly within the application process itself. A well-known example is SQLite, an OLTP in-process database. You simply include it as a library in your app, and it handles transactions and queries without requiring a server. So DuckDB, however, is an in-process OLAP database. While SQLite is a well-known in-process OLTP database, DuckDB introduced something new, an in-process OLAP database. Optimized for analytical workloads, it's really kind of a new database. And while it shared the simplicity and portability of SQLite, its goals and use cases are different. DuckDB is designed specifically for analytics and can run on virtually any platform, from laptops to cloud-based workflows. So yeah, DuckDB runs everywhere. And that's due to its in-process nature. It can live in any programming language and exists in 2 different clients: Python, R, Golang, Java, whatever is your jam, you name it. You just add the DuckDB package and you are ready to go. Another common way people run DuckDB without any language server is through the CLI. You download it no matter your distribution, macOS, Linux, and yes, even Windows, and you are ready to crunch data. Finally, it's also worth noting, like Doom, DuckDB can really run anywhere, even in the web browser through WebAssembly. WebAssembly WASM runs high-performance code typically written in C++ in browsers, enabling apps like Figma to work efficiently without a native install. So it's commonly used to speed up web apps by running compiled code alongside JavaScript. So if you go to shell.duckdb.org, you're gonna get an example of DuckDB running in the browser. Nothing is processed on any server because there isn't, and you can shut down your Wi-Fi to check it out, run a query, and everything is gonna work in your browser. Nothing is computed on the server side. How cool is that? And you know what else is cool? Liking this video and subscribing to the channel. Consider it as a gentleman's agreement. If you got value from this video, show some love. Or share it to your enemies if you didn't like it. So DuckDB extensions. So the last important bit to understand about DuckDB is its extension mechanism. I mentioned earlier that it contains a lot of integration to do your data work, and I like to think it as a Swiss Army knife. And DuckDB is designed with extension, where each specific function, like reading over Parquet or from Excel, yes, you can also do that, has its own specific extension. Some are core extensions supported by DuckDB, and some are because, yes, you can also write your own extension, write and maintained by the community. But enough talk, let's jump into the real meat and understand the basics of DuckDB while finding some fun insights about HackerNews. Like how often do people talk about ducks? For this hands-on part, we'll use the DuckDB CLI, but as a reminder, you can use DuckDB with multiple programming language, and it's just a library to install. A popular usage of DuckDB is also with Python, and if that's your jam, I prepare for you a shared collab notebook that you can click and follow along. And don't worry, no matter the client you are using, what you are going to see is mostly SQL. Once you initialize the connection, the rest of the code is mostly SQL. I'm going to use the CLI, which is great because it's easy to install, no programming language to set up, and it's pretty powerful. To install the CLI, if you're on Linux or macOS, you can copy-paste the one-line installation command on the website, run it through your favorite terminal, and that would just download the binary and make it ready for you. Note that if you're on macOS, you can also use the package manager Homebrew. And don't worry if you are under other operating systems, system like Windows, you can also either directly download the binary or use a package manager. Once your DuckDB CLI is installed, you can just launch it by using DuckDB. As you can see, I've opened my editor, which is here VS Code, and one workflow I like to use is basically open a SQL text file and just send the commands to the terminal. That way I can get my file, use all the features of my IDE, Copilot, autocomplete, and it's a really simple setup. The only thing I need is basically just a shortcut command. So for example, let's run our first SQL query like this. And as you can see, I just sent this SQL line to the terminal, the DuckDB CLI, and success. On VS Code, if you go to your shortcuts, you can use any key command to this command to send the text to the terminal. And of course, this kind of setup, you can reproduce it in any editor or IDE. And by the way, I made a full video on that topic if you're interested to watch, link in the description. All right, let's do a real query. We're gonna query a Parquet file over a bucket on AWS S3. And for that, I'm just using the from keywords and I just put a limit 5. And that's it. I can see the content of my HackerNews Parquet file with just one query. So how easy and fast it is. And that's the whole philosophy of DuckDB, to be easy to use. So note that our AWS S3 bucket is public here, and we'll come back on the authentication methods later. So a lot happened in this simple query, so let's break it down into 3 points. The first one is the from statement. DuckDB supports from first statement, and of course, it supports standard SQL. So this is the equivalent of doing select star from. But DuckDB has enriched SQL to make it even easier to work with data. That's a lot of easy. So this one is just a neat example of this friendly SQL dialect to increase your productivity when writing SQL. And I put a resource in the description if you want to have more example about this friendly SQL dialect. All right, the second point is the S3 URI scheme. As I said earlier, DuckDB works with extensions, and when you are creating a file over an S3 path, it will detect it needs to autoload some extensions as we are not reading a local file, but a file over an object storage. So here the httpfs extension is needed, which is part of the core extension maintained by DuckDB. So it is installed and autoload for you in the background when we run this query. And actually you can inspect what are the core extension available, install, and loaded. So if I go over here and run from DuckDB extensions, which is a table function, I see I have a column which is loaded and installed. And if I go over the httpfs I just told you about for querying over S3, you see this one is install, load is loaded and installed. Most of the time, core extensions are actually auto-loaded for you, but you might need it to install and load it manually. For install, if you want to use the spatial extension, then you just use the keyword install. So I'm gonna install the spatial extension and then I'm gonna load it. And now if I'm displaying again the table, you see here it was installed but not loaded. I can see the spatial extension is correctly loaded and installed. Another time you're gonna need to install extension manually is the one provided by the community, because yes, you can also write your own extension. So here, for example, if I go on the Google Sheet one, which enable you to read directly and write to a Google Sheet, you see I have to explicitly use the install keyword with the from the community. Note that with any open source project, you install this at your own risk. Those are not maintained by the DuckDB team, but that's roughly common sense. All right, coming back to our initial query, which query over S3, we noted that it used a from first statement, it's loaded the HTTPS function behind the scene. And a third point is that the format of the file is auto-detected as well. I haven't specified read Parquet function, for example. And there is a read Parquet function that I can use like this. So if I run this one, it's basically equivalent to the same. I have also more option on this read Parquet function. So I can pass different parameters needed if I want to, which it was not the case here, so you can just forget it. Again, simplicity. Of course, DuckDB supports multiple file formats from JSON, CSV, table format like Iceberg and Delta Lake. And again, behind the scene is loaded and install the right extension for you. Finally, it's worth noting that we've been working on AWS S3, but DuckDB support also querying from Google Cloud Storage, Cloudflare, and Azure. So all right, in one query, we have to understand that DuckDB has a friendly SQL syntax, supercharging basic SQL. It can read over S3 or other object storage specific file without any external dependency. And finally, he has an extension mechanism that most of the time will load and install internal dependency for you. All right, this is great, but how do I persist the data? Can I just also get the whole data ready to query locally to avoid back and forth to S3? Well, of course, DuckDB supports reading and writing to different file formats like Parquet, CSV, JSON, and others, but it happens also that DuckDB has its own file format. So let's talk about it. So DuckDB file format is an efficient ACID compliant format that contains all tables and all metadata. And I can store the result of my previous query into a table by simply doing create table HackerNews simple, let's say, and then has and my query that I just run above. So now when I'm gonna run this one and I can show all tables, I'm going to see that I'm going to have the table HackerNews simple that I just created. And I can query this one again with just the from first statement. And here I'm creating a local table of this simple of dataset. But if I exit the process, I'm doing Control D here of my terminal. I'm not anymore in the DuckDB process. Going back, again, another DuckDB process, show all tables, it's gone. And that's because of the nature of DuckDB of its in process. Everything is happening in memory, and by default, nothing is persisted on disk. So to persist the data, I can create a database. And a classic way to create a database file is to use the attach command. So let's say I'm gonna use my HackerNews stats, and then I can use any extension file name which works, but typically we use .db or .ddb for DuckDB database. So now if I do this, you're gonna see that because this file was not existing, it will create a database file. If the database exists, DuckDB will attach this database so that you can query all the tables and metadata that is in this database. Again, one command to make it easy, no matter if you create or attach an existing database. This command is also similar in other clients. If you're using Python, that works as well. Note that when you use the attach command, the default selected database is not the one you just attach. You do have to use the use keyword with your database name to select this one. So all the operation now is going to be by default on this database, but you can also, put all your query with the full name. If I include it, for example, here, the database name, that works also. All right, now let's recreate this table. Now, if I do all show tables, you see that I have a table in my database, my HackerNews stats, and a name of the table, which is HackerNews simple. If I exit the process, run again, run my attach commands, I can see that my table is there. This is not going to work because, as I mentioned, by default, you need to use the use statement, and you can query back the table from your HackerNews stats database. Small information, if you're using the CLI, you can also, when launching the process, just specify the database you want to read. So here, my HackerNews table, and therefore, you're gonna open a connection to this table and gonna make directly available to query that works. All right, let's test a bit how fast is DuckDB. I'm gonna create a larger table, and this one is roughly 10 gigabytes of data. So the first time, of course, when you create the table, it takes a bit of time depending on your internet connection. So now I have loaded this larger table into the DuckDB database. And so let's do just a simple count here to check what site. You can see I have 42 million row. So this dataset basically contain, as you can see on the file name, data from HackerNews from 2016 up to January 2025. And let's do a query a bit more complex now, where I'm gonna extract the domain name to kind of like know which is the domain website the most shared on HackerNews. And before running that query, I'm gonna add a timer. And for that, I can add the timer just by timer on. And now if I'm executing this query, you're gonna see that in less than a second, I have the results over this data set. And it queries so fast that you don't have time to blink. So let's attach actually another database. Let's call it HackerNews stats. And on this one, I'm gonna create a table, say top domains, has, and let me specify the full path of this one, the database and table name. All right, so now I have another database with the stats containing the top domains, and I'm gonna run another query, and this one is basically trying to see the DuckDB keyword. So when people are talking about Duck or DuckDB rather here, either in the title or in the text, and I'm computing over years and months, and you can see that things have been growing. So the data set is stopping beginning of January. So you see we have now roughly 50 times of mention per month on HackerNews, either in the title or in a comment, right? So one thing I can also do here, we can persist again this table under our HackerNews stats. So let's actually do that, and let's call it DuckDB mention has, and like this. I'm rerunning the query, and you see it's going really fast, roughly 1 sec. So now I have two databases. Basically, I have my HackerNews stats, which contain basically the raw table, and the HackerNews stats database, which contains the computed table around the top domains and the mention of DuckDB. So you see the performance here is really fast because I store data in DuckDB, and not only I have persistence, but performance is better, and that's just the general approach for any database. Typically, you have better performance if you use the native file format rather than an external file. Plus here, important here, I don't rely on my internet connection. My compute is close to my storage. But of course, if you want, you can export those data sets directly as CSV or Parquet. So let's do that to a copy command. So if I do copy and then my select query, so here let's say from HackerNews stats.duckdb, or let's say the top domains, and then basically to the format I want, and here I'm gonna export it as a CSV, and that's it. Actually, simple as that. So let me reopen my DuckDB process, which was still there. I just hide it for a sec. Running these commands, and as you can see now, I have my CSV file right there, which contain the top domain and the counts. So copying again, really simple. Of course, I can specify the file format explicitly and have option if it's a CSV to mention the delimiter and so on. But by default, again, DuckDB, recognized by the extension, the file format you want to export to, and do the magic for you. How easy is that? And important information is that DuckDB can also process data that doesn't fit all in your memory. It will spill it into the disk. All right, through this exercise with the attach and the database file, we learned that DuckDB stores the data by default in memory, and it can persist on this through a DuckDB file format that contains all table and metadata. We can attach one or more database as we did to the attach command, and you can export the data directly using the copy command based on a select query. All right, let's talk now about how managing secret, because the example was nice and easy because it used a public AWS S3 bucket. However, in the real world where we act all responsible as adults, buckets should be private and secure. So how do I authenticate to my cloud provider when using DuckDB? So DuckDB has a secret manager, and there are multiple types of secrets, as you can see here. And in general, you have two ways of creating secret, either temporary or persistent. As you can see here in the warning, persistent secrets are stored in an encrypted binary format. So the typical usage is usually temporary SQL. So this is, of course, the format you can do for S3. You provide the key ID and secret, and you mention the type. But in practice, you don't want to create static AWS keys, especially if you're running it locally, but you use IAM role. And if you use locally, you probably use the AWS CLI and use the SSO mechanism. So typically what you would do, you use your AWS CLI like this, so SSO through a defined profile, you authenticate, and so that would create basically the relevant secret in your .aws folder. Then when you launch DuckDB, you can now create a secret based on a provider credential chain. And so what it does is basically fetching the relevant SSO credential on your .aws folder. And I can check what is available as secrets with another table function, which is DuckDB secrets, and that's it. I'm ready to query private buckets. By default, again, those are temporary. If you want persistent, you can do persistent secret. But again, through SSO, it doesn't really matter because you have to refresh them again, mostly every day or every X hour. All right, so far we've been running the compute locally on our laptops, and storage can be separate and live on S3 as you've seen, but for some use case you need to scale either to a bigger machine or by scheduling jobs, and this is where the cloud comes in. And DuckDB can run in any process, so typically you could run it in any runtime, pattern runtime that you have already on your cloud. But then the question is, how do you manage your storage? How do you use your DuckDB database file? And how to make sure there isn't any conflict when writing. And how do you actually share easily this database file? And if it's running on AWS, then you still have this network back and forth. That's where MotherDuck comes in. It supercharges your DuckDB with features that turns it from a solo mode, let's say, to a multiplayer analytics experience. And the good news is that moving from a local DuckDB to a MotherDuck cloud is just one command. And authenticate to MotherDuck is also one command. And you can do that to any DuckDB client because anywhere you can run DuckDB, you can run MotherDuck. How easy is that? So let's open again another DuckDB process. I'm gonna attach the database that I created with the top domain and the number of mention of DuckDB. So if I show the tables here, I have two tables. And now let's say I want to connect to MotherDuck and move this data to the cloud so that I can share it to other people, but I can also use other BI tool or data visualization tool that will use MotherDuck, right, to create my dashboard. Because MotherDuck supports a lot in the data ecosystem tools. And for this, well, I need to have my data somewhere hosted so that, other people can create dashboards, for instance. So let's connect to MotherDuck with one command, and look at this. It's our famous attach command. So I'm just going to do attach, and that's it. Now I'm connected to the cloud, because if I do show tables, I'm gonna have a lot of tables because that's all my database also in the cloud. Let me just put a show database here and see I have 30 database in the cloud. How did that black magic attach to MD work? Well, the only thing you need once you log into MotherDuck and create an account is a token. MotherDuck has a free tier, so you can go ahead and play around. And once you have your account ready, you can go to settings, and basically you have your access token here, and you can create any access token that you need. So my access token is set up in my environment variable. So let me quickly quit again the DuckDB process to show you. And here I have the MotherDuck token variable, and so that's how it's authenticate. When using the CLI, for instance, if you don't have a MotherDuck token, you can also authenticate to a Webflow. So you click to a link, authenticate to the web application, and then you're good to go. But best practice is to set up a MotherDuck token as an environment variable. So yeah, going back to DuckDB and attaching and connecting to MotherDuck is just one line, and then you're ready to go and query on the cloud. And so now, for example, if I run this query, which look familiar, it's kind of like exactly the same query that we run, but it's used a database which is hosted on MotherDuck, right? So this sample of HackerNews dataset is hosted over there. So if I run this one, you see that now this query is actually compute on the cloud. And that's the beauty of DuckDB, because you have an in-process DuckDB database. You have now a database in your client and a database in your server that can act in concert. And that's what we call dual execution. It's a feature from MotherDuck, where we're gonna try to make the best out of each compute environment, would it be your local or client environments and MotherDuck cloud. So for instance, you can join data from your local storage with the cloud, and depending on the query, is gonna either push the compute on the cloud, which is the case here, or locally if it's a local database. And you can actually know that by running an explain in front of the query. So if I run an explain here, I can see I have my different operation, and R signify remote, which is run on basically MotherDuck. And then I'm downloading the result. If I'm attaching again my local DuckDB database, and I'm running same query, and let's say I'm just running an explain from HackerNews stats.top domains, you see that here everything is happening locally. Now let's say I want to push back the results of my local compute to the cloud. So I'm going to create a cloud database, which is going to be, cloud HackerNews stats. So this one is created on the cloud. And now I can create a table. Again, same semantic we saw. Let's say top domains has select from HackerNews.top domain. So what it's going to do here, you see it went super fast because, well, the data set is just a couple of rows. But now I have this table available as a cloud database. Of course, here I create a new table, but you can do insert statement if you want incremental loads, or you can copy a full database. Let's take the opportunity to explore the MotherDuck UI. The MotherDuck UI is essentially a SQL notebook. So you can have different notebook over there. You have your list of attached database, and we're gonna come directly here with the shared database. So first we have the attached database, and on my attached database, you can see I have my cloud network database, and you can see I have information here about directly the data here. The sample is really small, so it's not really relevant. But if you have the column explorer, let me share it with you on a larger table. So you see here, it's contain all the downloads from DuckDB on the Python. And I can see, based on the dates, the downloads increasing over the years especially in 2024. And so that's enable you to have quick information about the dataset without doing any query. Now, of course, I can start writing query here. And let's take the other query, which is based on a simple data, which is hosted on MotherDuck. This is a shared database. So we're gonna understand what a shared database is. But I just want to run this one and be doing mistake explicitly and running. So this is not going to work. And here we see you have fixit, which is gonna fix by line your query. So it detects the schema on the target table. And you see, that's probably a group by domain that you mentioned here. And it already doesn't found its URL. So yes, it's running. Boom. In 2 clicks, I fixed my query. So this query is again a shared database. And a shared database, as you can see, has this little icon here, which is, I have read permission on it. Now coming back to my database here, I can also decide to share this one. And here I have a couple of information. I can either make this available to my organization so anyone can access it or not. And I can also make it public with a link, and I can create share like this. And you see this command is just an attach command again. So if I'm running any DuckDB client and I'm connected to MotherDuck, I can attach the shared database just like this and start querying it. And so we have a couple of shared database with open dataset that we maintain. I invite you to go to our documentation on the example datasets. You see we have the HackerNews database, either a sample or the full dataset. We have Stack Overflow data with some schema and some query to run. And of course here I use the UI to show you around the MotherDuck UI, but you can of course use any client to create a share and just do create share, my name of the share, and then the database you want to share. And that's it. All right, the last thing I would like to do again with MotherDuck is querying file over S3. And while this is important because first, if you want to query over an object storage, you need secrets. So we saw how the secrets manager for DuckDB works. Now, how do I query using the MotherDuck Cloud Compute? I need to have the secret store over there. And so for that, let's take back the command we use for DuckDB and just add in MotherDuck. Now my secrets using my SSO mechanism, I'm already authenticated locally using the AWS SSO CLI. I can create the secrets, and all the secrets is available for MotherDuck. So now I can start creating private buckets using MotherDuck. But that's not the only thing fun, is that I can use the network bandwidth between MotherDuck and AWS. So if I run a query there, I'm not anymore depending on my internet connection. So let's do a small benchmark. We're gonna run the same query, but directly over S3, so without any intermediate step where we load the data from S3 to a DuckDB table. And we're gonna first do this by just using DuckDB without MotherDuck. So let me run the timer on and then the query. All right, so it took 11 seconds for this specific query to run. And now let's do the same, but through MotherDuck, still using my DuckDB client, but now I'm gonna leverage the cloud compute and network bandwidth between my buckets and MotherDuck. And boom, 2 seconds. So hopefully you see the advantage clearly of having a storage and a compute on the cloud and a DuckDB client locally. You can do a lot of different things, optimizing your costs when you need to compute locally, or leveraging the cloud and the network between your blob storage if you have data out there. So what we learn about MotherDuck is that authentication is just through one command to the attach and a MotherDuck token provided in your environment. Moving data from a local DuckDB to MotherDuck is just one query. You can just do a create table as you would create a table locally, but you target a cloud database. I can create a share to easily share cloud database. I can do this from any DuckDB clients. Anywhere you can run DuckDB, you can run MotherDuck. I can leverage the MotherDuck UI to use the SQL notebook, the AI fix-it features, or the Colin Explorer. And I can leverage a cloud network to speed up querying over object storage and safely secure my secrets. All right, let's wrap up. We had a lot of things to talk about why DuckDB is such a game changer for analytics. Whether you're crunching data on your laptop, scaling up in the cloud with MotherDuck, or just amazed that a database can run inside a browser. Hopefully you learned the core concept around DuckDB and also around MotherDuck. And we have a lot more resources around DuckDB and MotherDuck, so feel free to check the links again, yes, in the description. In the meantime, keep quacking and keep coding.
Quack.